So hello, classmates, and hello, panelists, and everyone who joined here. And firstly, before I start going with my project, I want to congratulate all my classmates for this wonderful projects that I have been seeing. I'm really enjoying them. And right to start with my particular capstone project final presentation. So I know most of us in this particular meeting or cohort has been drivers, and we have been driving for quite some time, and we have might come across this particular situation when we are driving. We will wave a hand, or we might be indicating something with the indicators or switching on the lights and conveying something to the other driver. So that's where our project is about: investigating driver to driver communication, a human centered design approach to enhance driver situation awareness. So this is our project. And this is my team: Roshini, Deva, Aditya, Deshmukh, and Manideep, and we are advised by Professor Feng Zhou. And just to start with the user research, I would like to start with a small story. So this was the story from one of the user. So the user, along with his wife, was driving on a freeway on a summer afternoon, and all of a sudden they ensured to get this brake failure in their car, and they were actually trying to stop the car, but they couldn't because there was a brake failure, and they were trying a couple of different other ways. But meanwhile, they're so much tensed, or they are so much annoyed because they might be hit by the car behind. So they have been trying all the ways to open the windows and wave it to the drivers outside or the cars behind, saying that, we encountered something. And the couple were shouting, and while one of the driver, you can see, he was trying to control the steering and move to one of the shoulders so that, they might be in the safe place. So this was one of the incident that grabbed my attention, and that grabbed the particular project research. So we were actually looking to understand what are the pain points in the current driver to driver communication, and we want to overcome that. And this is the short story from one of the users that we have interviewed. And the main objective of this project is to understand what exactly are the communication between the drivers. What are the pain points in the current situation? How a device or how a technology or how a design can enhance this particular communication better and have a better communication on the road, so that there are less accidents and there is a very joyful way of riding or driving. And to give you a background, and while we were researching for this particular project, we understood that drivers want to share something like emotions with the other drivers. Whenever there is a mistake done from the other driver, we will be actually emotionally drained, or we will be affected with that particular reaction. And drivers are actually influencing. If I'm driving within my own way, but still I'm influencing someone on the road, and there is more often the frustration or the emotional imbalance in between the drivers when they are on the road, and when there is a driving happening within their the area. Coming to the research methods, so to understand more, we went and performed a literature review of how exactly the things were working, and what were the papers, or what were the earlier research which taught regarding the driver to driver communication. And we came up with 33 different papers, and finally which were relevant was 18 papers, and we were actually able to get some insights on what are the factors that are affecting the driver to driver communication, how this particular factor, or there was a device in one of the research paper which actually collected the communication from one driver, and it was passing to the other driver in the different car. And we also have done the focus group, and we did two focus group with 11 participants. And what were the main highlights of the literature review? So there was like I mentioned, there was a device which captures the emotion of the particular driver, and it shares that particular emotion with the other driver. So it might be somewhere in the form of voice, somewhere in the heads-up display, and they were displaying the messages on the road with the heads-up display and also the windshield display, and they were actually using the headlight display to showcase something there they need on the road, so that the driver behind can notice it, or driver in the front can notice it. And studies have explored that interactions among drivers are autonomous cars and manual cars. So there were more of manual cars where the driver to driver communication was there in need, but most of them also prefer to have a autonomous, like they don't want drivers to take that burden. Instead, the car should actually communicate it with the other car. That was the intention that most of the participants in previous literature review mentioned. And coming to the scenario, so based on the papers or based on the personal experiences that we have done, we have come up with 11 crucial scenarios. And I know there are many more that can be added up, but it all depends on what is the timeline that we are taking to ensure that more scenarios. But these are like the crucial scenarios that we have found out. So, for example, the sudden parking on the side of the road. So that way, for example, if a particular car suddenly stops on the side of the road, it actually is causing something, or it is actually affecting the car driver behind. And he might be frustrated, or he might be annoyed, or he would like to honk, or he would like to, open the window or say something, because that's when, you are in a speed and you have to control because of other person. And we have also found out that there are four various factors, which are person related, situational related, vehicle related, and cultural factors. When I mean person related, so it might be based on the person's mistake. For example, the situation that I was talking, sudden parking on the side of the road, comes under the person related situation. And after the focus group, we have got lots of qualitative data on what exactly are the inputs from the users. And we came up with four different sections. One is the pain points, user requirements, and ideas, and also the scenarios. For example, one of the user was saying that it's very anxious. They feel anxious when are driving. So someone honks at them, mostly the female drivers. They don't want someone to honk because they feel that honking might disturb their driving behavior. So this is one of the pain points that was said by the user. And they were actually expecting a device or a design or a technology where they can communicate easily with the other driver, and it has to be responsive, and it has to be very fast, and it has to be universally understandable. And we had different ideas, but these were some of the major ideas that we have come across from the user. So they need a convenient way. So when we are driving, I know we are holding a steering, and we have a couple of things to focus on. So they want something so that it is easily convenient to send the message to the other driver. So these were one of the ideas. And these were other user mentioned scenarios. So one of them would be the lane merging. So whenever a user want to merge into a freeway, it's very difficult. We have to focus on many of the things. So they added this particular scenario to be part of the scenario that we want to do research and also build the design. But yeah, due to time constraint, we couldn't focus on considering this scenario, but we came up with a couple of design scenarios where we can help with that case as well. And now I will hand over to my colleague Roshini for the next steps.
Thank you, Manideep. Next slide, please. So we have used a creation technique with total participants of 6. Three of them were actual users, and then we have generated 160 plus ideas using Crazy 8's method. We then curated these 160 ideas into 3 using card sorting. Next. So the first idea was a connected vehicle application. This would be a feature that works with both Android Auto and CarPlay. From this application, the user can select the predetermined set of messages to send them to the driver with whom they want to communicate. Information about the vehicle will be displayed on the screen, and the messages will be shown on the map. Users can also send an audio message through this application. Next slide. So idea number 2 was different types of indicators. Here, this indicates special types of communication, such as having an indicator with different colors, as in green or orange lights on the car, so that other drivers get an idea of what's happening. And the last idea was display at the front and back of the car. If the driver wants to communicate, they could select predefined signs from the provided interface and communicate with other drivers using the display located at the front or back of the car. Next slide. So this is the whole process of generation, curation, and conclusion. So after comparing these 3 ideas, considering various factors such as usability and understandability of the users, and the one that addresses the intent of communication of most of the scenarios we considered, we decided to work on the third idea, which is having a display at the front and back of the car. Next up is the prototype of the finalized idea. For our prototype, we first identified the intent of communication from the scenarios, and we have come up with 3 design variations for all the 8 scenarios. This is the first design variation, which is traffic sign. First design variation, we'll be using traffic signs on the license plate at the front or back of the car to communicate. And these are the 8 designs designed for the 8 scenarios. The second design variation is using emoticons on the license plate at the front or back of the car to communicate. And these are the 8 different designs for the 8 scenarios. And finally, the third design variation is next slide. So the third design variation is using text on the license plate, and this shows the 8 designs for the 8 scenarios. Next slide. So for this whole process of research and design, we have used various tools and methods. The first one was Google survey forms for gathering facts, attitudes, behaviors, and opinions. And we moderated a focus group in person. And the second was Figma. We used PigJam to organize and analyze the data to categorize observations, and Figma to design the ideas. And next we have used Adobe Premiere Pro for prototype making and editing. After prototyping, we have used Qualtrics for usability testing and distributed our survey on the Prolific platform. Moving further, Aditya will walk you through the usability test process in detail. Over to
Uh,
Aditya for detailed analysis.
Thank you, Roshni. Okay, now after we created the prototype and the designs, it was time for user testing. So for the user testing, we designed our experiment. Next slide. Uh, so we conducted a between subject study by using the online survey. So, to get the data, we used Prolific website and we paid participants approximately $1 to each participant after the completion of the survey. The survey was designed in such a way that approximately 3 groups of 40 participants received 3 different design variations. So totally we got 120 responses from the online survey. The participants were from the United States having valid driving license, and the age group was between 20 to 50. Next slide. In the experiment procedure, we first asked the participants to fill the consent form, and then we asked them the demographic questions such as their age, gender, education level, and driving experience. Then we trained the participants by showing the sample format of the questions in the survey and a video. Random designs were assigned to the random participants. Then we started asking the questions related to the metrics. We asked questions related to situational awareness. Then we ask question about technology acceptance models. Then we ask questions about understandability using Likert scale, then mental workload, and at the end we asked open-ended question. Next slide. So the measures, the first we measured situational awareness. Situational awareness refers to the user's ability to perceive and understand the current situation, including the status of the other vehicle, traffic condition, and potential hazards. To assess the situational awareness, we asked the questions such as what grabbed your attention in the video, which scenario is presented in this video, and identify the design on the front car display. Next. Next is technology acceptance models. Here we measure the perceived ease of use and perceived usefulness. Perceived ease of use refers to users' perception of how easy or difficult it is to use the driver-to-driver communication system. It takes into account the complexity of the system. Yeah. So perceived usefulness refers to the user's perception of the system's usefulness in achieving their goals or completing their task. It takes into account users' needs, their preferences, their expectations, and how well the system meets those needs. We ask participants to rate the statements on the Likert scale based on the judgment. And the statements were like, this type of communication would enable me to accomplish the task quickly. Next slide. So understandability refers to the extent to which the design of the driver-to-driver communication system is easy to comprehend and operate for the user. It includes clarity of the designs and text, user interface, and other design elements that affects the user's ability to understand and use the system. So for this metrics, we ask participants to rate the statement such as this type of communication of how the front vehicle behaves is satisfying. And this type of communication of how the front vehicle behaves has sufficient details. Uh, yeah, next slide. So mental workload. Workload refers to the level of cognitive effort and mental activity required by the driver to perform the communication task using each design variation. So like it can be affected by the factors such as complexity of of the design, complexity of the interface, the amount of information presented, the speed of the communication, and the level of distraction from driving. And lastly, we ask open-ended question. We ask this question to understand the positive and negative aspects of the design. Next slide. So yeah, you can go back. We chose this 6 factors to determine the effectiveness of the different design variations. Now let's check the analysis. First, we check the mean and standard deviation of the situational awareness and created the bar graph. As you can see, there is a difference between the values of the 3 designs. So we conducted one-way ANOVA test to compare the means of 2 or more in like 3 independent groups that are text, emoticon, and traffic signs in order to determine whether there is a statistical evidence that the associated means are significantly different. So we had the null hypothesis that there is a significant difference between the means of the 3 design, and alternative hypothesis that there is no significant difference. So after the calculation, we found that for the situational awareness, all the combined scenarios, the p-value is 0.03, which is less than our alpha value, which was 0.05. So our null hypothesis was true. And we found that text-based, so our null hypothesis was true. So which means that there is a significant difference between the 3 designs. And that's why we conducted a post hoc analysis to check which design was better. And we found that text-based designs are significantly better than the other 2. Next slide. In case of perceived ease of use, the p-value came out to be 0.278, which is higher than the alpha value. So we interpreted that there is no significant difference between the means of the 3 designs, that is traffic sign, emoticon, and text. Next slide. Okay, yeah. Similarly, for the perceived usefulness, the p-value was like greater than the alpha value. So there is no significant difference between the 3 designs in terms of perceived usefulness. You can go ahead. Next slide. Yeah. In terms of understandability, the p-value and the p-value and alpha value had marginal difference. So we interpreted that there is a marginal difference among the 3 designs. And in the post hoc analysis, we found that the text-based designs are marginally better than the other 2. Next slide. Yeah. So for the mental workload, the p-value was much greater than the alpha value. So there is no significant difference found in the 3 designs. Next slide. So here is the summary of the one-way ANOVA test. So we calculated one-way ANOVA test by combining all the intents as well as individually. And we found that for the perceived ease of use and perceived usefulness, there is no significant difference between the 3 designs, even in the individual scenarios. But in case of understandability, the scenarios which shows the intent, such as sharing information and convey emotions, have marginal difference between the 3 designs. And in terms of situational awareness, the scenarios which shows the intent of sharing information or performing tasks and understanding, like getting more understanding, indicates that there is a significant difference in the 3 designs. Next slide. So for the responses of the open-ended question, we conducted thematic analysis. We arranged the comments into positive points and negative points, and then we came to the results. Next slide. Yeah. So we found three themes. The first one was effectiveness, and we found that the traffic signs and the text were more effective than the emoticons. And participants found the design simple and straightforward. So they appreciated the short messages that were easy to read and process quickly, making them useful for cars traveling in the same direction. Participants also noted that the designs provided a quick heads up of what the intentions of other drivers were. The next thing we identified was distraction, and participants expressed concern over the distracting nature of the designs in all the three designs. Participants were worried that these designs could cause more problems than they solve, particularly if they are not a common thing. Like if the designs are design vary, then it's difficult to understand. They noted that the signs were too large, making them hard to see at night or in the rain. The last one was clarity. Participants in all the three designs expressed concerns about the clarity of the message. Participants found some signs were hard to read quickly and had too much text, and which causes the distraction. So we combined the results from the statistical analysis and the thematic analysis and found that the traffic signs and text received the positive feedback. And then text designs are better than the traffic signs and emoticons in terms of understandability and situational awareness. Next slide. Yeah. So for the conclusion, the first point is learning. We learned a lot during our capstone. We learned that during the ideation phase, it's better to have other stakeholder as well. This can lead to innovative and effective solutions. Another point, we learned that user research is a critical component in the design process. So yeah. Uh, so next point is observation. So we've observed that this type of communication can be helpful in the case of vehicle to pedestrian communication, as well as in case of autonomous vehicle communication. We faced some challenges in this project. One type of challenge was creating an interactive prototype to test. We wanted to use simulation-based prototype for testing, but due to limited knowledge of the simulation software, we were not able to do it. And the last point is future scope. So this design should be checked with the pedestrian communication as well as autonomous vehicle communication in the interactive prototype simulation. And US department is also working on this problem. So we are looking forward to it. Uh, thank you. We are open for the questions.